morning, Lindsay.
Lindsay's a high school sophomore, but she's already thinking about career options.
Science and math are probably what I would want to go into as a, career when I'm out of college.
Still work. Straight ahead.
She likes everything about science.
I've always liked medical science. I always watch medical shows, and I've always been interested in prenatal development and genetics. And I really like chemistry a lot, and I'm excited to be taking physics next year. And then I'm thinking I might take advanced bio. Okay, so
In fact, Lindsay is so good at science that she skipped the basic 9th grade science class completely.
Which is nice because then I get one more year of other science. One more year to take another science class.
Just kind of rough it up a little bit with the steel wool.
Okay.
This year, in chemistry, there's quite a bit of lab work. Lindsay's teacher is learning new things too. It's the first time he's taught a student who is blind.
I have to think ahead, several days, because I have to have all of my materials converted over to Braille. And then in lab, so much of chemistry labs are visual. So I've had to train the kids that she works with to describe everything.
And what's happening?
The nails are just rusty.
Okay, nails.
Lindsay may have a slightly different experience from her classmates, but the knowledge she's gaining is the same.
The color changes aren't just to see, oh wow, it's turning blue. The point is to see, wait, copper is blue. Okay, that's why it's turning blue.
Here's the controls for the telescope.
An interest in science or math is a great benefit to 21st century students, leading to exciting career options. And success in those fields does not depend on perfect hearing or vision.
There's an amazing number of very successful scientists and researchers that are blind, totally blind.
So find the Burke Museum.
Richard Ladner is a computer science and engineering professor at the University of Washington. He's working with a group of graduate students on software which will be helpful to students with visual impairments.
The title of the project is Tactile Graphics Project. And what we are trying to do is develop a software that can convert graphical images into tactile form as automatically as possible.
Tactile drawings, or raised line drawings, are not new. Tim used them when he was a medical student at the University of Wisconsin.
I use raised line drawings, which can represent things such as cross-sections through the brain or what another student might see on a microscopic slide. And this helps me understand the same material that the other students might pick up visually.
It can be time-consuming to convert images to a tactile format. The ideal is to make that process simple so that any visuals can be made accessible in a timely way.
The transcribers can convert the images much easier than now. Currently, it takes about 4 or 5 hours per image, but it is possible to conversion process in just a few minutes or something like that.
Other accommodations vary depending on the type of lab work being performed and the needs of individual students. Students with visual impairments may need a variety of options. For students with hearing impairments, accommodations focus on one area.
The main issue there would be communication and making sure that the person has an interpreter, a sign language interpreter, and things like that, so that they can communicate with their colleagues.
Other communication tools include captioned videos and lab instructions in writing. And for students who are hearing impaired but not deaf, an FM system allows them to hear the instructor.
I've got the new digital technology right now, and what it does, it has a little boot that connects onto the hearing aid, so it's wireless. It's really cool. And it's basically a digital connection from the microphone box, which you connect to the speaker, and then it would transmit the information to this little boot.
Testing? Does this work okay? What you're going to do is hook the crayon to one end of the string that you've tied. The other end is hooked to the two thumbtacks, and as tight as you can, draw an ellipse.
Whoa.
Allan Roth taught science at Washington State School for the Blind. His students had a wide range of visual impairments.
I think you need to realize that each student's an individual, so I will read and find out about their eye condition, some eye conditions, there's no central vision, but there's peripheral vision. So I have to read ahead of time and do my homework and make the modifications based on what the student's needs are. You're going to put the crayon, and you can show Jonathan, and circle all the way around.
Oh, I get it.
Okay, cool.
Oh, that's neat.
Some of those modifications are homemade. In this class, for example, students are making ellipses with a clipboard, string, and some tacks.
What number is this? I use meter sticks that are brailled. I use graduated cylinders that have flotation devices in them so you can measure liquid level. If we're studying a cell, I'll get something like a glue gun, which I use a lot. I'll use fabric paint, and I will draw it on paper, and then I'll raise it up with just the lines from the glue gun or the fabric paint, and then I've got a ready model that's dried in 20 minutes and I can hand to a student. It really is easy to do.
Commercial products are also available for lab work. Allan uses a number of these with his students. A talking thermometer.
The indoor temperature is 23 degrees Celsius.
A thermometer with enlarged numbers. And a thermometer with braille numbers. A triple beam scale with deeply filed notches and glue dots to mark 1 gram increments. A light sensor with audio signals.
And it measures the intensity of light or how much light is filtering through. Red, orange, yellow.
A graduated cylinder with large print, and a notched plunger marked in 5 milliliter increments. Raised line drawings with braille labels. Other possibilities include enlarged models, enlarged specimens for dissection, 3D geometric shapes and molecular models, and braille labels on equipment and materials.
And more of the iron nails is flaking off.
Students can take lab notes using portable braillers or microcomputers with text-to-speech software. For Lindsay's chemistry class, she also uses a larger Perkins brailler to make scientific notations. She takes her exams in the Student Services office.
And the last test that we had was on balancing chemical equations. So I write the test. They convert the test to Braille. They give her the test in Braille. Then she uses the special chemical symbols brailler.
Did you have a chance to look over the lab?
Yeah.
So you know what's going to happen?
Yeah.
Kay Adamson, in the Student Services office, offers support and assistance to both students and teachers. Before Lindsay started chemistry class, Kay offered advice to her teacher.
Just sort of teaching him a little bit about blindness, like what kinds of things he might need to pay attention to in his class. For example, when he writes something on the whiteboard, to say what he's written, or to just kind of check with Lindsay. When he's giving a demonstration, we've tried to adapt some of them so that Lindsay can see all the pieces when he does the demonstration. He tries to stand in front of her when he's talking about, when he has a model, for example.
Why do you think it's green? It was blue before.
Because of
The iron.
The iron, that's right.
And of course, Lindsay herself is a good resource for teachers.
She's been doing this a long time. She's been accommodating to school longer than I've been accommodating my classroom to her. So she knows a lot of things that she needs.
Yeah, that's what's nice about an eyepiece. Here's the focus right here. You can focus it for your eyesight.
Sean, another student who loves science, would agree with that. He's learned how to accommodate his visual impairment during lab work. Microscopes were a particular challenge.
Microscope is generally pretty small, and then even when you have something even smaller underneath it, I can't see details sometimes, so I have to use the television, like a television linked with the microscope.
Sean's done his own frog dissection, but relied on his lab partner for assistance with a fetal pig.
He told me what he was doing cutting-wise. I can basically, cutting the parts open and cutting the cavity open and opening them up, and then tell me what he was pointing to or how he was doing something, because I couldn't see well enough to do it myself.
Sean uses beakers with enlarged marks, materials with large print and high contrast, and sometimes enlarged drawings of organs for things he can't see during dissection. And besides working with a partner, he collaborates with his teacher on accommodations.
biggest thing I can recommend to anybody is just talk to your teacher and modify your experiments, because a lot of stuff were too dangerous for me to do without a partner or by myself. Just have the teacher help you either after school or before school. Just find a way to do it, because it's really fun when you can do the experiments.
First, I'll send around the skull of a man.
Marcia Ogilvy has seen the classroom from both sides. She was in college taking science classes when she became blind.
In human genetics class, I used pipe cleaners to build strands of DNA, human DNA. And they work perfectly because it's basically a ladder-like structure. And you could do random mutations and stuff like that by taking rungs out of the ladders or putting different size rungs back in the ladders that connected the two strands of pipe cleaners. And so it worked real well.
Marcia went on to study biological anthropology in graduate school. She found that studying bones worked well as a tactile experience.
If you know the structure of a bone, then if there's an abnormality there, it jumps at you instantly. So that's how you can get at disease processes that have affected bones. For right now, we're going to tell the police, well, that doesn't look like it could be hers. It might be someone else.
Marcia's business is analyzing bones to determine whether they're prehistoric or modern. And if modern, she looks for medical or legal significance. She has advice for students who plan careers in science.
They need to take major responsibility. And you just have to, by your example, show people what you're capable of. Because if they haven't tried it, they don't know.
Go.
For teachers and professors, the most important element for success may be attitude.
Okay.
Expect participation, listen to your student, and be willing to make accommodations.
You're going to encounter all kinds of different people in your life, and you just can't go along the way you normally do in some situations, and you have to give a little, and you will actually get a lot out of it. You know, my advice to faculty members is just adapt a little bit. After all, this blind person has to adapt a lot.
Seek advice from disability services staff at your school and work with the student to determine what, if any, accommodations are necessary, and allow students with sensory impairments to achieve their own success in the classroom.
There's always ways you can work around the labs, there's always ways you can put blind people to do science, and as long as you develop good communicative skills and just being able to, develop the skills in order to get it done, it's definitely doable.
For more information, contact Do It. World Wide Web, www.washington.edu/DOIT. Phone, voice or TTY, area code 206-685-DOIT. Address, Do It, University of Washington, Box 355670, Seattle, Washington, 98195-5670. Director Cheryl Bergstaller. Funding for this project was provided by the National Science Foundation, Cooperative Agreement HRD 0227995. Copyright 2005, University of Washington. Science is possible for everyone. Do It scholars can tell you how.
It's real helpful for kids like us with disabilities when teachers are flexible.
It is very important to include every student in an activity, being disabled or not.
Just help out, give information where needed. I don't appreciate secretive instructors very much.
I want them to know that that I can do anything.
Do It stands for Disabilities, Opportunities, Internetworking, and Technology. Students in the program learn to be successful themselves, becoming experts on their own accommodation needs. Then they share their experiences with others. Here, Do-It participants show how students with disabilities and science teachers can work together in learning partnerships, multiplying the possibilities for academic and career success. Students can help teachers to develop creative alternatives for gaining and demonstrating knowledge. First, we'll look at gaining knowledge.
It's really important for a science teacher who has visually impaired students in their class to, first of all, describe anything that needs to be described. So if they draw something on the board or the overhead, describe it as best as they can, and then provide the student with a copy of the drawing to either be drawn tactily or enlarged so that they can see it and see what the drawing looks like.
The computer has made doing schoolwork a lot easier. The computer I use has a voice output. It also is helpful for doing research over the network.
The instrument that I use in school to do my work is a magnifier and a binocular to see the blackboard, and the overhead I won't be able to see well because of the light reflection, so the overhead isn't really helpful. It's helpful if the teacher explains what he or she write on the blackboard.
I have muscular dystrophy and I use blood different books to see the print better.
When I'm in any class, including science classes, I always inform the teacher or professor that I do indeed have a vision impairment, and so they're not surprised if I ask for something a little different than normal. If they do have an extremely small handout, I will ask that it be enlarged.
I have a hearing impairment, and in a science lab, I prefer written instruction from the teacher or on handouts and stuff so that I can visually see it and not have to concentrate so hard on listening and get every single step. And I also like it when the teacher writes instructions on the blackboard or an overhead projector, and it makes it a lot easier for me to understand what is going on in the class.
Sometimes I need a sign language interpreter. A lot of times I use a FM system, which lets me hear the teacher only, and I have a receiver which goes directly into my hearing aids.
I had a stroke which paralyzed me on the right side of my body, and just this whole thing affected my memory and just how to get concepts of things and stuff like that. If a teacher could give me visual things to look at, and if even touch, that helps me so much better. Lectures do not help at all, because I need to see things, and just that helps with the concepts.
My disability is LD, which is a learning disability, and it affects me in that I'm a very slow reader. I read every single word individually and process it, and so obviously the speed does not increase. And so hopefully the computer can sort of take over my mother's job in that I can increase the speed that it reads to me, and so I can increase the speed of my reading.
When you have a disability like I have, it's hard to write everything down that you need to write down. It would be nice if there were a computer at my disposal that I could use to write things down with, and that I could view things through, instead of having to always have somebody pull something out for me or do something for me. I can just do it on my own.
I'm very interested in space. With the internet, I can access NASA's big computers and get pictures from their telescopes in space.
The main point that I think is really critical for a science professor to know is that a lot of the adaptations can be done right within the laboratory itself, and that the professor has the knowledge with a little extra effort to make those adaptations so that the laboratory is accessible.
The teacher shouldn't feel like it's all up to them. It's very much a cooperation between the student and the teacher.
There are many ways to gain information, but the most important element is good communication between teachers and students. Learning styles and accommodation needs vary. A few common adaptations for improving access to information include enlarged print and braille, an interpreter or FM system, visual aids or models, extra time to receive and process information, computer technology, and the internet. Once lessons are learned, students have to show that they understand the material. For students with disabilities, there can be challenges involved in demonstrating knowledge.
Science labs are normally pretty difficult for me unless they have a shorter workstation and like the microscopes can tip and whatnot.
Like I've had to have a stool so I can get up to the lab tables to work on the things, or to wear an apron. I couldn't wear one, so they had to staple and kind of hem up an apron so I could use, but that's all I really required. But often it's only little things that people require so they can participate just like anyone else.
I'm an amputee, and the main advice I'd give to a science teacher is to put me with a partner when we do labs, because of some of the things I can't do, and they can help me out with it.
I need less labs that deal with colors. A lot of the labs say, watch for the color change. I can't do that. So change of shape or heat or texture I can do easy. They would make, science a lot more interesting for me.
The hardest part in the science lab is writing the information down about the lab and the lab results. It's better if I have time to go home that night and do that on my computer or have someone else write it for me. The computer helps me because it has a spell check and a grammar check and can be read easier than my handwriting, because my handwriting is bad.
I can't write at all with my hands, so I use the computer to write my papers and communicate to other people.
A lot of the time I get my like worksheets and stuff like that for school on Braille or on tape, and if I could get them over the computer, it would be a lot easier if the teachers would just send me, for example, over email a worksheet. I could work on it with the computer and then send it right back.
My disability is Lyme's disease, and it's affected my immune system and my energy level a lot. So it's been hard going to school, and in the past I've had to be homeschooled a lot. And about the only adaptation I need for a science lab would be flexibility in the scheduling and a flexible teacher, because I may need a different time than the class set time.
I take at least twice as long. Whenever a teacher gives a quota of the amount of time you should spend on homework, I automatically double it because I know it'll take that long.
In a written test or a lab situation, each student will have individual challenges involved in proving knowledge. Some common arrangements could include computer use, alternatives to standard equipment, alternative procedures, or flexible time arrangements. It just takes a little bit of creativity, patience, and common sense to allow every student to participate in class.
A lot of the time, the student has to prepare ahead of time so that he or she knows what to expect, and then to sit down one-on-one with the instructor and to go over the points and see how they can adapt the experiment ahead of time. And it's important that the professor tries to come up with ideas as well as the student.
I can do it. Just be patient. I can do it, and I really enjoy it. And so just be aware of what's there and work with it. And so far my teachers have been really great about that.
I think it's very important that science teachers understand that people with disabilities can do science. We have the intelligence and the capabilities to do it. And it's important that we're exposed to science just like people without disabilities are, so that we can better make choices about the rest of our life, like what career we want to go into and what we want to study.
For more information, contact Do It. On the World Wide Web, www.washington.edu/DOIT. Phone, voice, or TTY, area code 206-685-DOIT. Address, Do It, University of Washington, Box 355670, Seattle, Washington, 98195-5670. Director Cheryl Bergstaller. The creation of this videotape was made possible by a grant from the National Science Foundation. The University of Washington College of Engineering and Computing and Communications also contributed resources to this project. Copyright 1998, University of Washington.
Disabilities, opportunities, internetworking, technology. That's Do It.
Do It makes me feel like it really can happen, like nothing can stop now.
At Do It, we're all about success.
Being independent is something that's really important to me.
It's like you actually did it by yourself, yay!
Success in college.
I want to study computer science.
I learned how to do a web page.
Success in careers.
I'm really interested in technology and engineering.
Success in life.
Making friends is really big.
You don't feel alone here, you feel equal, no matter what.
Do It programs are made possible by the National Science Foundation, the U.S. Department of Education, and the state of Washington. We're also supported by generous gifts from corporations and individuals.
You'll learn so much and you'll love it.
To support Do It, call 206-685-DOIT or check out our website at www.washington.edu/DOIT or write to us at Do It, University of Washington, Box 355670, Seattle, Washington 98195-5670. Director Cheryl Bergstaller.